Okay, I'm going to do a mini lesson on the regression equation and predictions and residuals. So this kind of includes section 5.2, but also 5.3 as well. So the regression equation. So we talked about, when we're collecting data in the real world to figure something out about a population of data, um, it doesn't exactly match a pattern. So what we do is we'll plot the data, right? And in our case, we're focused on linear relationships. So we look at the data and we'd say, okay, here's my data, here's my dots. Does this reasonably represent a line? Does it kind of look like a line? Does it take a linear shape? So what we would do is we would try to draw a line and say, okay, yeah, it kind of looks linear. And if we drew that line to represent the relationship between these two quantitative variables, x and y, and we drew a line, we'd want to have it fit that data as best we could. And we'd want to do that by minimizing the distance between the line and each dot. So in other words, right, we wouldn't want to put the line here, right? We wouldn't want to make the line like that. We'd want to minimize the distance. We want this line that best fit the data that we collected. And that's all when we have a regression line, or when we call it a line of best fit. All I did was I plotted my data and I came up with an equation for a line that best fits the individual data I have, and that's called linear regression. That regression just comes up with a line that will show the relationship regression between my x variable and my y variable. X is always representing our independent or our explanatory variable, and it's always on the horizontal axis. Horizontal axis. All right. Our Y value is always on the vertical axis. And what that means is we're looking at, as X changes, what happens to Y. Can I explain, or is there a relationship between X and Y? In this case, as X increases, Y is increasing. Okay? And then if we say, yeah, that line looks pretty good, we could use that line to predict any value of X. That's the goal. We want to see, can I use this line to predict values of Y if I put in a value of X? All right. So residuals, what are residuals? Well, once I come up with this line here, right, I have all my actual data points. A residual is just measuring what's the difference between what the line predicted versus my actual data. It's just a measurement of how well my actual data tracks to this prediction line. So a positive residual means, in this case, here's my actual data. Down here in the purple is what my line predicted. In this case, right, this actual data is above the line. If I take actual minus predicted, it's going to be a positive number, right? My actual value is greater than the predicted value. So this distance here is positive. It means my actual is bigger than my predicted. It means that my regression line underestimated the true value or the observed value. That's all my residual is. I'm just comparing what did I actually see versus what is the line predicting. And a negative residual would be like a point down here. So if this is my actual, and up here is where my line predicted a value bigger than. my actual. So in that case, the line is overestimating as compared to my actual data. Let's take a couple examples. So here is this foot length example that we've used a lot. So let's say we just describe this as, oh, we are doing a study, we're interested, is there a relationship? Specifically, we're only interested in linear relationships. Is there a linear relationship between foot length and height? They're both quantitative variables. We can measure them. All right. In this case, foot length is our explanatory variable, our x variable, also called our independent variable, foot length. When you get a table like this, you are going to get your x value first and your y value second. All right. So we want to know, is there a relationship between foot length? Is it related to height? We can call that a response variable, our y variable, our dependent variable. Does our height depend on the length of our feet? All right, so in order to determine that, we can't capture the entire population and look at the relationship, so we take a sample. We took a sample of 20 people, we measure their foot length and their height, and this is it in the table here. So we wrote down foot length is X, height is Y. We need to put them in coordinate pairs because we want to plot them as a scatter plot. Here's all my 20 data points here. So what we can do is we can cut, when you're in Lumen, you can just cut and paste your data. Okay. And if you go into Rossmann Chance, what you would do is you would clear your data. All right, and this is going to be foot length and height. And now I can paste my data in here, and I'm going to use that data. Click Use Data. You want to make sure that n is equal to whatever your sample size is. I took 20 samples. It's going to plot my data here. Foot length is on the horizontal axis or the x-axis. Height is here. So what I want to do is I want to click Show Regression Line. What that does is it takes our 20 data points and it does a mathematical calculation to come up with this line, this best fitting line, to minimize the distance between the dots and the line. I do want to show you here, you can also show residuals. So if you click on any dot, it's going to show you, it's going to calculate the residual for you. You need to know how to do it by hand, but I want you to be able to use this as a way to check your data. All right, anyway, so when you click regression line, it comes up with the regression line here. It says the estimated height, that's what that hat means, that's my y, is equal to 38.3 plus 1.03 times foot length, x. All right, let's go back to my other. Okay. That's all you have to do to get the regression line. You just are going to put it into Rossmann Chance and it's going to give you the regression line here. So let me just connect it to what we've done so far. All right. We talked about y equals a plus bx. Y is the response variable, in this case, height. The hat just means it's an estimate. That line that we get out of Rossmann Chance is a way to predict height given any x value. All right. A is our vertical intercept. In this case, it would be 38.3. B is our slope. That would be 1.03. And x is our explanatory variable or our foot length. That's all it's doing. It's coming up with a linear equation or our regression equation to predict a y value when we put in an x value. All right. if you try to think of things in terms of X and Y, I think it'll help you out a lot when you try to solve these problems. Okay, so again, this is my X, this is my Y. Okay, so what did we do? We cut and paste our data. We put it in the linear regression applet. We created a scatter plot. Okay, we had the tool calculate a line of best fit right here. All right. So here's my actual data. Let's take this actual point here. A person that I actually took data from, I measured their foot. It was 24. Their height was 66. That's my actual data. So we collected data. Someone had a foot length of 24 and a height of 66. 24, 66. I can write it as an ordered pair. So if we say, what does the line predict? We got this best fit line. What does the line predict if someone had a foot length of 24? Well, I just used this line, okay? My estimated Y value, or my estimate for height, is equal to 38.3 plus 1.03. I'm going to substitute in 24. When I do that math, the line predicts that if you have a foot length of 24, that your height will be 63. So there's a difference between what I actually saw, 66 inches, and what the line predicted, 63 inches. So what is the residual? Well, the residual is just wanting you to see what was the difference between what I actually observed and what the line predicted. What's the difference between those two? And did the line overestimate the Y value, or did it underestimate the Y value? So in this case, even before we do the math, here's my actual value, 66. The line predicted something less than that, 63. We already can kind of see that it underestimated the Y value. But let's calculate the difference. Let's calculate the difference between those two values. That's our residual. If I take my actual observed Y and I subtract from it my predicted Y, my Y hat, all right, my Y actual was 66 right here, and my line predicted 63 here. So all I'm doing is I'm just taking the difference between those two. 66 minus 63.02 is 2.98. That is my residual. My actual value is greater than my estimated value, so the line is underestimating. Okay. Let's look at it here for a second. Okay, so let me just go back. 24, okay. So this is the dot we're interested in here, and here's the line. We can see that it's my actual here is above the prediction. So the line is underestimating. So you can actually see it here as well. All right, and let's go back. Let's do another one. So let's take another data point. Let's do no more practice. So here is our line of best fit. That hasn't changed. Our estimated value of height is equal to 38.3 plus 1.03 times foot length. So if we say, what does this line, the regression line, predict for height when foot length is 30? I'm just going to take this line. I'm going to substitute in 30 where I see X. I calculate that, 69.2. What did my actual observed data show? Well, here's the particular data point I'm looking at, when this person's foot length equaled 30, their height was 74. I can write that as an ordered pair. My foot length is X, my height is 74, that's my Y. Okay, up here, my regression line predicted that when foot length was 30, that height is 69.2. How well did that regression line predict height when I compare it to my actual data? All right, well, the way I'm going to do that, I'm going to take what was my actual Y value when foot length equaled 30. I'm going to subtract from it my estimated. That's my residual. I'm just finding the difference. I'm finding how well did the line predict. Okay, my actual Y value is 74. When I put it in the prediction line to calculate it, I got 69.2. The difference was 4.8. The estimated value here is less than the actual value. That means my regression line underestimated height for this particular data point. Here's my picture. Here's my actual data point. When foot length equaled 30, height was 74. That's right here. My estimated on the line is down here. When X equals 30, the line predicted height to be 69.2. Here's the difference, is this value here, 4.8 inches. And my actual is bigger than my estimated, so the line underestimated. Okay, I'll do some additional problems as well. I'll post those later.